Today, we're taking a step back, way back, to a time before life even existed on Earth. To a time when our planet was nothing but a raw, unformed world of raging volcanoes, crashing lightning, and oceans of churning, lifeless water. And in this chaotic environment, we're looking for something extraordinary: the origins of life itself. Let's rewind the clock by about 4 billion years, when Earth was young and forming. The land was barren, the seas were acidic, and the sky was a turbulent swirl of gases: methane, ammonia, carbon dioxide. But missing was the oxygen that now sustains us. The stage was set, the ingredients scattered, and the question that follows is one that has captivated scientists for generations. How did life begin? The journey to answer this began in the 1950s, when scientists Stanley Miller and Harold Urey recreated what they thought could be the atmosphere of early Earth. They filled a flask with water, methane, ammonia, and hydrogen, and then ran electric sparks through it to simulate lightning. After just a few days, something incredible happened. Complex organic molecules began to form. Amino acids, the building blocks of life, appeared out of this simple mix. This experiment showed that, under the right conditions, life's essential ingredients could indeed form naturally. But was this enough to create life? Other scientists wondered if life might have started not in shallow pools, but far below the ocean's surface, around hydrothermal vents. These vents are like underwater chimneys, spewing superheated water rich in minerals. Despite extreme heat and high pressure, these vents are filled with life, even today. Microorganisms cling to the sides, thriving on the minerals and chemicals that pour from the Earth's crust. This theory suggests that life could have emerged around these vents using chemical reactions for energy instead of sunlight, and adapting to the extreme conditions of Earth's earliest oceans. But there's another possibility, one that might change how we think about life's origins completely. Scientists have discovered amino acids and organic compounds on meteorites, hinting that the ingredients for life could have come from space itself. This theory, called panspermia, suggests that the seeds of life might not be unique to Earth at all. Perhaps these building blocks came aboard meteorites or comets, delivering life's essentials from distant stars to our own planet. Each theory, the primordial soup, the hydrothermal vents, and panspermia, offers a glimpse into how life might have begun. But even with these insights, there's something remarkable about the mystery that remains. We know that somewhere along the line, simple molecules form chains, clusters, and ultimately something truly miraculous: the ability to replicate, adapt, and evolve. From the simplest single cells to complex organisms, life found a way to grow, survive, and reach for the stars. Think about this for a moment. The spark that started life on Earth is connected to each one of us. We are all part of a journey that began billions of years ago, shaped by forces we are still only beginning to understand. From stardust and chemical reactions to consciousness, we are connected by a single thread that stretches back to the first flicker of life on this planet. So, where does that leave us today? Perhaps it leaves us with a sense of wonder. Maybe it reminds us that while the origin of life may still hold its secrets, the journey of discovery brings us closer to understanding our place in the universe. It reminds us that life is not just a scientific question, but an invitation to explore the depths of who we are and where we came from.